Hello, welcome to this lesson. In this video, you're going to solve this question I have on the screen, which is that a single phase motor connected to a 400 volts and 50 hertz supply is developing 10 kilowatts of power with efficiency of 84% and a power factor of 0.7 lagging. Calculate A, the input apparent power in kilovolt amperes, and B, the active and reactive component of the current, and C, the reactive power in kilovolt ampere reactive. So let's look at how you're going to solve this question. So the first thing is to calculate the input apparent power, okay? And then from my previous lesson on power in AC circuits, we learned that the power factor should be equal to the active power over the apparent power, okay? So we can use this formula to find the apparent power. So you're going to have the apparent power to be equal to the active power over the power factor. Okay, so we know the power factor of the circuit, which is 0.7. Okay, but we don't know the active power, but we can find the active power. From the question, we were told that the motor developed a power of 10 kilowatts, which will be the power output of the motor. Okay, and then we know the efficiency of the motor also. So we can use this to know the apparent, so we can use this to know the active power, which is the power that the motor consumed. Okay, so when we're able to know the power that the motor consumed, we will be able to find the apparent power. So we learned earlier on that the active power is the power that is consumed by resistive devices, and then in this case the single phase motor will be the resistive device in this circuit. So the power that it will consume will be the same as the active power, which is the P that we are looking for. So to do this, you are going to use this formula: efficiency equals power output over power input, okay, expressed in percentage. So we already know the efficiency, which is 84%, and then we know the power developed or the power output, which is 10 kilowatts. So you're going to have the power input, which is the active power, to be equal to power output over the efficiency. So when you do this, you're going to have the power input, which is the active power, to be equal to power output, which is 10 kilowatts, 10 kilowatts divided by the efficiency, which is 84%. So 84% is like 84 divided by 100. So I'm going to have this. So let's simplify this and see what you get. When you do this, you're going to get 11.905 kilowatts. Okay, so this will be the active power. So now that we know the active power, we can find the apparent power. So you're going to have the apparent power to be equal to 11.905 divided by the power factor, which is 0.7. Okay, so when you do this, you're going to get 17 kilovolt ampere. So this becomes the apparent power. Okay, so the second question says we should find the active and reactive component of the current. Okay, so let's look at how you are going to do this. So just like we have a phase diagram for the power in the circuit, we're going to have a phase diagram for its current. Okay, so you're going to have something like this. You know that the active power goes in this direction, and then we have the reactive power in this direction, Q, and then we have the apparent power in this direction. Okay, so for this reason, you're going to have the active current in this direction, active current here. Then you're going to have the total current here, I, and then you're going to have the reactive current, which I represent with IR. Okay, so that same reason. And then we will have the phase angle here. Okay, so what will happen is that you want to find the active current and then the reactive current. Okay, And then we already know the power factor too. So we can use the power factor to find the phase angle. That is, if only we know the total current in the circuit. So how do we find the total current in this circuit? So let's look at how you're going to do this. We know that the apparent power is the total power in this circuit. Okay, so that's giving us apparent power equals the total voltage in the circuit times the total current. Okay, so this is the current that you are looking for. If you're able to find this current value, we will be able to find the active and reactive component of the current. So you're going to have the current to be equal to the apparent power over the total voltage, and this total voltage is giving us 400 volts. Okay, and then we know the value of the apparent power too, which is 17 kilovolt ampere. Okay, so you're going to have 17 times 10 to the power 3 because of the kilo divided by the total voltage, which is 400 volts. Okay, so this is volt ampere, and then this is volt. Okay, so the volt will cancel out this. So you're going to have the current to be equal to 17,000 divided by 400. Okay, so this will give us a value of 42.5 amperes. Okay, so this will be the total current in the circuit. Okay, so now that you know this current value, you can go ahead and then find the active and then the reactive component of this current. Okay, so from this circuit here, we can take cosine of the phase angle, which is cosine of phi, okay, which will be equal to the adjacent side over the hypotenuse. Okay, but in this case, we are using the current, so you're going to have IA over hypotenuse, that's the I, okay, and then we want to find IA, okay, so you're going to have IA to be equal to I cosine of phi, okay, and then don't forget we learned earlier on that the power factor PF is equal to the active power over the apparent power, and then this is the same as the cosine of phi. Okay, so let's not forget this. So wherever I see cosine of phi, it also means the power factor in this case, and then that is given the question as 0.7. Okay, so we have this here. So from here we can see that the active current should be equal to the total current, which is 42.5 times cosine of phi, which is the same as the power factor, so that will be times 0.7. So let's simplify this and see what you're going to get. I have a little interaction here. Let's continue. So you have 42.5 times 0.7. So that will give us a value of 29.75 amperes. So this will be the active power. Okay. So now we want to find the reactive power also. So let's look at how you're going to do this. Okay, so to find the reactive power, one way I will want us to do this is to find the phase angle first. Okay, so we know that cosine of phi, which is the power factor, is equal to 0.7. Okay, so to find phi, that will be equal to the cos inverse of 0.7. Okay, so let's find this value. So let's find phi. So cos inverse of 0.7. Okay, that gives us the phase angle. So that gave me a value of 45.57. Okay, so this is the phase angle. So now what you want to do is that you want to find the reactive current. Okay, so for that one you can use sine phi, okay, equals the opposite, which is the reactive current over the hypotenuse over the total current. So you're going to get the reactive current to be equal to the total current times sine of what? Phi. Okay, so this will be equal to 42.5 times sine of 5. So that be sine of 45.57. Okay, so let's simplify this and see what you are going to get. So you have 42.5 times sine of 45.57. So that gave me a value of IR to be equal to 30.35. So you have 30.35 amperes. So that's the value of the reactive component of current. Okay, so the next part of the question says we should find the reactive um, power in kilovolt ampere reactive. So let's look at how I'm going to do this also. Okay, so we learned earlier on that the reactive power Q, okay, should be equal to the apparent power, okay, times the sine of 5. Okay, this is what we learned earlier on. Okay, this will be equal to the reactive power. Okay, so we already know the value of the apparent power, and then we know phi also, which is 45.57. Okay, so we can actually find the reactive power. So I'm going to have Q, okay, to be equal to 17 sine of 5. Okay, and then phi is 45.57. Okay, so let's simplify this and see what you're going to get. So we have 17 multiplying sine of 45.57. Okay, so when I did this, I got 12.14 kilovolt ampere reactive. Okay, so this will be our answer. So that's all for this video. Thank you very much for watching. Please make sure you like the video and subscribe to the channel.